A, B, C, D. Okay, these are the resistors. So this kind of questions are common, like what is the effective resistance across the points AB and CD. So for the purpose of solving it, I will just draw one more circuit. So I'll even try to have it slightly bigger. Okay, so what is the effective resistance between A and B and C and D? In fact, the question might look like this: what is the effective resistance between points AB by CD? What is the ratio of these two effective resistances? Here I'm going to introduce one more new concept which we have already seen. Okay, suppose first, if you are supposed to find out the effective resistance between 2 points A and B, then you connect those 2 points across a battery to see which way the current is going. When you look at here, when the current comes here it is provided with 3 branches, so the current divides. But you see, whatever the current goes through this, the same current goes through this. That means that these two resistors are in series. So this circuit, these two resistors can be replaced with a single resistor 3 plus 3, which is 6 ohm. But this 6 ohm is still there. So this 6 ohm is still there. And this is the point A, this is the point B. And you look at here, whatever the current goes through this 3 ohm, the same current goes through this. So that also, these two are in series. So 3 plus 3 becomes 6. So right now 3 6 ohm resistors are in parallel. That means that effective resistance will be, if identical resistors are in parallel, effective will be the value of the identical resistor by number, which is 3. So 6 by 3, which is 2 ohm, which we discussed in the previous video. Then what is the effective resistance across the point CD? So the next point CD we have to. So what we do is, let me just do the same thing. I will just copy this and we'll do the change in orientation, because we need to find the effective resistance between C and D. C and D or D and C, both will be the same. When you just look at how the current goes, when the current comes here, it goes here, and then here it divides, and then it divides, and then it will all join. But you look at the resistor, like 3 by 3 and 3 by 3. If this resistance is P, this is Q, this can be redrawn for our purpose, for clarity purpose. You can redraw this like this. So this is 3, this is 3, this is 3, this is 3, this is 6 ohm, and this is the point C and D. Suppose the ratio of these two resistors and these two resistors are same. 3 by 3 is 1 and 3 by 3 is 1. In that case, then the current through this resistor will be 0. Then you can remove this. When you remove this, you know what, when you connect this to a battery like this, when you connect this to a battery, what happens? Whatever current flows through this, go through this, this. So 3 plus 3 becomes 6, 3 plus 3 becomes 6. Now that it is 6, and then this is 6, this is the point C and D. Now 2 equal resistors are connected in parallel. Effective will be 6 by 2, which is 3 ohms. So there it is 2 ohm, it is 3 ohm. So RAB by RCD, RAB by RCD equal to 2 by 3, which means that 2:3.